If you are watching this, you probably finished the course. Episode 37 was the finale. The whole machine taken apart from Turing's question down to a student model learning from its teacher. So consider everything from here a bonus round. New supplementary deep dives for people who went the whole distance and want to keep going into the ideas that are genuinely dominating the AI conversation right now. And there is no better place to start than the single biggest shift in the field since the transformer itself. For years, there was really only one way we knew to make a language model smarter. Make it bigger. More parameters, more data, more training compute. Then, around late 2024, a different idea took over. And it is so simple, it sounds like a trick. What if you just let the model think for longer before it answers? Quick note before we dig in. If you find this useful, subscribe and drop a topic you want explained in the comments. Now, let us get into it. Here is the whole idea in one sentence. A reasoning model spends extra compute at inference time, generating a long internal chain of thinking before it commits to a final answer, and that extra thinking makes it dramatically better at hard, multi-step problems. The name for this is test time compute, sometimes called inference-time scaling, and the word test time is the key. Everything you learned in this course so far treated the model as a fixed thing. You trained it once, at enormous cost, and then every time you used it, it did roughly the same amount of work. It read your prompt, ran forward once, and streamed an answer. Fast, cheap, and for a lot of tasks, good enough. But for the truly hard problems, competition math, tricky code, multi-step planning, that single quick pass was a ceiling. The model blurted out the first thing that came to mind, and if that was wrong, there was no second chance. So think back to how we described a plain model all the way back in the early episodes. Next token prediction, one pass, streamed out word by word. A reasoning model still predicts the next token that never changed. What changed is what those tokens are for. Before it writes the answer you actually see, it writes to itself. Thousands of tokens of private deliberation. It proposes an approach, tries it, notices the approach is going wrong, backs up, tries a different one, checks its own arithmetic, catches a mistake, and only then writes the clean final answer. If you have used a model that shows you a little collapsing thinking panel before it responds, that is exactly this. Those are called thinking tokens or reasoning tokens, and they are the model's spending compute to think out loud in a scratchpad before answering. It is the difference between blurting and deliberating, and researchers sometimes borrow a phrase from psychology for it: fast system 1 thinking versus slow, effortful system 2. Let me make this concrete with the two models that define the category because the numbers are genuinely striking. On the OpenAI side, the Yo series, models trained specifically to reason, where a small model like O4 Mini, by most reports, tops the charts on the AIME and MATH competition benchmark despite being far smaller than the giants it beats. Which tells you something profound: the reasoning matters more than the raw size. And on the open side, the one that shook the whole industry, deepseek won. On the 2024 AIME, a brutal high school math Olympiad qualifier, R1 scored right around 80%, sitting just behind OpenAI's O3 in the low 80s. An open model, trading blows with the best closed reasoning model in the world. And here's the detail that shows you the mechanism directly. When DeepSeek updated R1, its accuracy on the 2025 AIME jumped from roughly 70% to around 87.5%. How? In large part by thinking more. The average number of tokens it spent per question climbed from around 12,000 to about 23,000. Read that again. It nearly doubled how much it thought, and it got substantially more right. That is test time compute in one clean before and after. The dial you are turning is not the model size. It is how long you let it think. Now the natural question is where this reasoning ability even comes from, because no human sat down and wrote out those thinking steps. And this is the part that made researchers sit up. It comes largely from reinforcement learning. You take a base model, you give it hard problems that have checkable answers, math where you know the final number, code where you can run the tests, and you let the model try. When its chain of reasoning leads to a correct answer, you reward that whole path. When it leads to a wrong one, you discourage it. Do that across millions of problems, and the model gradually discovers, on its own, that behaviors like checking its work, considering multiple approaches, and backtracking tend to lead to rewards. Nobody taught it to say, wait, let me reconsider. It learned that reflection pays off. DeepSeek's big result was showing that this reasoning could emerge from pure reinforcement learning without first-hand feeding the model a pile of example reasoning traces. A cousin of this idea is the process reward model, where instead of only grading the final answer, You give the model feedback on each individual step of its reasoning, rewarding a good move even in the middle of a long solution. But I want to be honest with you, because this is a course that respects your intelligence and thinking longer is not free. Every one of those thousands of thinking tokens is compute you are paying for in money and in latency. A reasoning model might burn 15,000 tokens of private deliberation to hand you a 3-sentence answer, and you pay for all 15,000. This quietly rewrote the economics of the whole industry. For years, the working assumption was that inference, actually running the model, was the cheap part, and training was where all the cost lived. Reasoning models broke that assumption almost the moment they shipped, because now a single hard query can cost more than it used to cost to answer 1,000 easy ones. So the real skill, the thing that separates someone who understands these models from someone who just reaches for the most powerful one every time, is knowing when the thinking is worth it. And the dividing line is sharp. Reasoning models earn their cost on problems that are multi-step and verifiable, hard math, real debugging, planning out an agent's actions. They are wasted pure burned money and latency on lookups, simple chat, and formatting, where a fast standard model would have nailed it in one pass. Do not pay a model to deliberate over what day it is. So how does this land depending on who you are? As an individual, this is why the toggle in your chat app between a fast mode and a thinking mode actually matters. Use the fast one for drafting an email. Flip to the reasoning one when you are stuck on a genuinely hard problem and you want the model to grind. As a startup, this is now an architecture decision. You route the easy majority of requests to a cheap, fast model and reserve the expensive reasoning model for the small slice of queries that truly need it. Because getting that routing right is often the difference between a product that is profitable and one that quietly bleeds money on every chat. And as a large enterprise, reasoning models are what finally make the highest stakes work. Complex analysis, code that has to be right, multi-step automation, reliable enough to trust, but the compute planning is real. An analyst pointed out that inference demand is now projected to dwarf training demand many times over, precisely because every one of these queries thinks so hard. So let us bring it home. A reasoning model is not a bigger model. It is a model given permission to think before it speaks, spending test-time compute on a long internal chain of reasoning, taught largely by reinforcement learning to check itself and backtrack, and it trades money and latency for a real leap in accuracy on hard, verifiable problems. Exactly the way DeepSeek R1 got better by nearly doubling how many tokens it spent per question. This is the new scaling axis. Not just bigger, but longer thinking. And it sets up everything in this bonus round because once a model can reason through a hard multi-step problem, the obvious next move is to let it actually do something with that reasoning. Give it tools. Let it act. In the next episode, we go inside the thing a lot of you are probably using to watch this course get built, AI coding agents, and we take apart exactly how a model reasons, reads a codebase, edits her files, and checks its own work in a loop. The bonus round is just getting started. That is the core of it. If this helped, hit like and subscribe, ring the bell for the next deep dive, and tell me in the comments what you want broken down next. Thanks for watching.